Hi. I'm going to talk about monitoring distributed systems, generally speaking, okay? I'm not going to use the mic, so if you can't hear me, come close, or I'll start whispering so you can come closer to me. I'm going to talk the context of monitoring in distributed systems, okay? I'm going to give you a little bit of background, then kind of tell you a little bit of my experience with monitoring, and that's why the title is How It Can Save Your Bacon, because it saved mine. And I'll do a short demo also of the particular software platform that focuses on messaging on the .NET platform. It just gives a good kind of visualization of what I'm going to talk about, okay? So it is self-promotion of particular, but it's part of the deal, I guess. But what the talk itself is general and not specific to any kind of software. So I guess most of us have done, you know, the traditional N-tier system. We had a little website talking to a little database, and then it became a big website talking to a big database. And what we used to do is kind of hack it on our computer. Anybody used to do that? No? FTP, the thing, the files onto, yeah? Yeah, we did it, yeah. So that's how I started, and that's how we did it. And we basically kind of pushed the files up to the server. I went up to the, you know, HTTP, yeah, it's working, we can log in. Then I went on to kind of monitor what's going on. And I left it, you know, like that's more or less it, right? The next time that I'm going to bother with it is, you know, somebody is complaining, or accidentally going to the website and see that it's down, right? All the millions of customers are probably waiting to come in, right? At that time it was like, you know, 5,000 customers was loads. So we're not there yet today. We're not there today, and the next level was, you know, I started working for blue chip companies, and we still were kind of FTPing stuff up. Yeah, there was not DevOps, was not real. There was the operation team, and we wrote specs of how to deploy the software, and we deployed the software, and that's it, right? You know, we gave somebody, you know, tested. We came in the morning, just made sure that, you know, the night batch ran okay, yeah, and gave it to ops, right? And ops, what did they do? Nothing. They had their monitors. They had the, you know, monitoring. Is the web service up? You know, the database up? Yeah, probably, or not. Can the web server talk to the database? Yep. Everything's green. That's it. We go, right? And what were we actually monitoring? You know, the very basic stuff in life, yeah? Is everything running? So it's kind of infrastructure level, yeah? The connections are all right, the network is green, or nothing's burning, there's no red alerts. The higher level, I guess, is, you know, is the application process running? Can I log in? Does the nightly job work, yeah? That's like the kind of more application kind of monitoring. And the higher level is kind of business capabilities. Can the user log in and do something meaningful and it still works, yeah? So, you know, if I do something on the website, will I get an email? Yeah, that's a good example. It's functioning, yeah? I can see a whole thing going from end to end, and it's actually the business process is working. I'm borrowing this kind of Maslow's hierarchy of concerns. Do you know that thing? So in the bottom, it's like life. The needs is life. In the middle, it's like, you know, getting to the next level of awareness and all that. And the top is, I think, self-realization or something like that. So very kind of, so same concept, okay? So we were monitoring in the infrastructure, is everything good? In the application level, we checked that, you know, the application is actually running and performing the tasks we expect. And that is like the least of what we were actually checking. Yeah, we did it once and that's it, right? That's fine. Everything's working. If we look from trying to enrich this kind of those aspects of monitoring, we can take that the monitoring area as being the most kind of basic look on the world, like the aspect that just checks the basic stuff, and it would be the infrastructure, the application, and the business capability. That's one aspect of the pyramid, if you wish. On the other aspect is the monitoring concern. What are we checking? What are we testing? And it's health, performance, and capacity. You know, I'm running out of disk space. That's something you would only think about when you run out of disk space first time, right? Most of the time we just say, oh yeah, the 10 gigs on the server, that's okay, you know. And the third aspect is the interaction type. So passive is what I described earlier, right? I deploy it to production and hope everything's going to be fine. Reactive is, yeah, I have some monitors, I have some things that are going to send me emails or PagerDuties, and I'm going to be reacting to crisis. So every time something breaks, everybody goes into firefighting mode, and you know, in the war room, we solve the problem, and then we go back to sleep, right? And the proactive kind of monitoring is where you go and you say, okay, I need to be a lot more proactive about my business, look more into things like the business, the application, every level, every aspect of monitoring in a proactive way. That means that I write code, not only log everybody does that, right? We try, catch, throw, exception. What does that do? Write to the log, right? And that's it. Now, you know, then we go to progressive mode where we have some kind of aggregator running on top of our logs and raising events if things look not normal, or at least allows us to kind of interrogate the logs. Then we can go to an even higher level where our code actually provides us with warnings. Yeah? The code goes and there is a problem here, raise an event, send a message, send an email, raise something that would cause an alert or something like that. For example, heartbeats. Yeah, heartbeats is something that is a plugin or something you write that sends a heartbeat to something, and if those heartbeats stops, you know that there's a problem. Another one would be if you're kind of looking at business funnels, for example. Yeah, so business funnels would be like, you know, I expect for a number of orders that come in, I expect so many emails to be sent. If a user starts a journey on you know, is a converted user, he starts some kind of checkout process, based on the fact that 90% will drop off that, we know the statistics. If it drops below that, we have a problem. If that consists, there's a bigger problem, right? Does that make sense? So this is kind of like progress up you know, from being very passive, just looking at the strictly health kind of thing, we can go into a lot more complex, a lot more proactive monitoring, and also provide, you know, as a byproduct, you provide a lot of business value, because all of a sudden you go to business and say, is that all right that we get, you know, if you think about is the 90% funnel, you know, is that okay for you? Because maybe you should optimize it. Maybe it should be 95, maybe 99. You know, if we monitor and we constantly write to our dashboard information about how many orders are done a day, the business don't need to do reporting. They just go to our dashboard and they know that they did 10,000 sales, or so many users are currently on the site, and how many users have dropped off in the last 10 minutes, the last 30 minutes, how much time people are spending on the site, for example, is something that very much interests marketing people and all that. So, but we can tie it into our coding and the way we build stuff. So after, you know, I grew up a little bit and understood that monoliths don't work very well, and I started distributing stuff. So my first attempt was something like that. Yeah, you know, I didn't rewrite and build a microservice architecture and you know, all the buzzwords. I just you know what, there's the email, that's a real problem. I have, constant issues with email. Put it on its own little thing. Put some queuing in the middle, and every time I needed to send an email, I just called this method in my business logic, sent a message over to a component, and that component, all it did is, first of all, never lost my emails, so all the emails were tracked. And the other, it was like all the problems of SMTP. Back then, it was more problematic than today, I guess, and it was very slow and tedious, and that component just chugged along in the background. I didn't care about how many messages are in the queue, and then I did the same for PDF, and then I had some integration with CRM that used to be synchronous, so every time somebody hit the screen on the front end, it would talk to the CRM. And so I started distributing. So now we don't have this one thing, right? We now have 3 things or 4 things, and all of a sudden it's like a whole distributed world. My later projects ended up with hundreds of servers and endpoints, but it's not relevant. It's the same concept, yeah? So each of those servers were its own kind of thing. And one thing that's very different to monoliths is that now, because of durable messaging and because of the fact that the architecture is built for failure or acknowledges failure, it means that this server could be chugging along in the background, receiving messages and doing nothing. Yeah, because nothing should fail. The process will still, you go ping that server, it's alive, the network is okay, there's no alerts. It's not, if you don't know that the business has stopped working there, you wouldn't know that it's down, right? If you have to go into the message queue to see that messages are being consumed, that there's some movement there, yeah? Or obviously, if you're storing your messages on disk or in the database, then you might end up with no disk space or quotas. You overrun your quota, something like that. Have you done this with messaging? Happened to you? I'm sure somebody did. So we're stepping into this new world where if we don't take monitoring seriously, then we might just our system may run, but it's going to do very little business processing. Yeah, and in this scenario, we're getting to be a lot more interested about what's going on in the queues. What's happening there? What's happening with our messages? How are they moving around? What are the actual performance look like? Are we hitting our SLAs, right? Because messages can just sit in the queue forever. And we need to do a lot more kind of proactive monitoring. So let's talk a little bit about queues. Who here does microservices first? Any kind of distributed? Okay. Who doesn't use queues? Everybody is using queues here, right? Okay. Just checking. If you don't use queues in a distributed system, it doesn't matter. It's called microservice service-oriented architecture. Name the next buzzword that's going to come. You're doing something very wrong if you're not using queues. Yeah, it's very. Can you see? It's kind of small. I'll give it. So we have like endpoints. For each endpoint, we can see the queue length. So how many messages are sitting in the queue? We can see the throughput. So throughput is the what can this endpoint process. In this case, it's per second. So what this endpoint can process in 1 second. Okay? Then we see something that's called scheduled retry rate. And if you did messaging, and most messaging systems, one of the basic concepts is, if I can't process a message, I do automatic retries, right? I put it to, I try again. Doesn't work in our platform at least, NServiceBus. It goes to delayed retries or second level retries, as it was called. And those retries, it means that we put the message back in another queue. we time out, we remember to come back to it, and we try to process it again. And if that fails, it ends up in the error queue. So we have an error, okay? But we never lose the message. That's the concept, okay? Is that okay with everyone? Make sense? So that retry is very interesting because it means that something is delaying me, right? I'm sending a message over to an endpoint, and then it's chugging, it's like repeating the same operation, but nothing is progressing, right? So that's an interesting metrics to look at. And processing time is the time that it takes from the second that I invoke the handler, so I start processing the message, actually moving my bits and bytes to do something with it, to the time I end. So if you wish, I entered the method until the time I went out of the method. And critical time is the time that the whole process takes, from the moment that I take the message off the queue to the time that I'm deleting it off the queue. So I close the whole circle, everything is there. So obviously the critical time will include the time of retries, would include any kind of waiting in anything in the pipeline. Okay? So critical time, as I said, it's the time it takes to process the message, to process the message end to end. Processing time is the time that it takes to take a message off the queue and finish handling that message. And the other matrix is the retry, and the retry is very much aligned with how many how much time it's how many retries we're doing while we're trying to process a message. So when we look at moving away from monitoring for the sake of monitoring, just make sure that everything's working, there's a very interesting byproduct from that. If anybody, I don't know about you, I'll tell you a little story at the end, but if you try to debug a messaging system and understand where your bottlenecks are, it's kind of walking in the mud, right? A big waist-high mud, yeah? And we go in, open MSMQ or your queuing system, trying to look into every queue, what's holding that queue, trying to figure out what's the problem with that. I don't know. If you don't have tools that actually do it for you, it's a nightmare. So doing it ourselves, we can go to, I don't know, NServiceBus, Azure Service Bus, or RabbitMQ. You go to the control panel, you can see number of messages in the queue. So it tells you that currently there's like 10,000 messages in the queue, but it doesn't tell you anything about what is going on, which message types it is, and so on. Yeah? If we have something to understand what are the properties of those messages, what types they are, which handler is handling them, if we can peek into the message and go, oh yeah, this thing is because of, there is a payload that's a problem here or something like that, it helps us a lot more to optimize what's going on. For example, most scenarios is that you have loads of handlers, loads of message types, and they all end up in one queue. Yeah, you send it to one process. You don't distribute from day one. At least in the old days, we didn't used to do that. Today, with microservices, everybody distributes from day one. But I won't tell you what I think about it. But we might have this scenario where we have the very important message that needs to be processed and high priority. That the $1 million order sits behind 10,000 messages of send email to a client about this promotion that we have, right? And if you're able to look at your messaging system, you can learn those things very quickly and then go, okay, that $1 million handler, the one that handles my best customers' orders, I will take it, put it on a single process, put it over there. It has a separate queue, a separate machine, all the network in the world, whatever we want to allocate to it. And we can look at the system and go, just like in a glance, we can say, oh, there's this one endpoint that's constantly filling up with messages. Let's look at it and see what's stopping it. Okay? So, demo time. I have if that doesn't work, by the way, I'm warning you. If that doesn't work, I have a video that you can watch that kind of does the demo. Basically, what we want to show here in the demo is like this very, how do you say, naive example of a system where a client sends messages to the sales endpoint. The sales endpoint publishes that the order placed, an order was placed to the billing and shipping. Billing goes and charges the credit card and publishes an event to the shipping endpoint that the credit card was charged, and now shipping creates a like a ticket to put on the box. Yeah, so you can ship the product. And you can go to that if you want. You'll see how simple it is to run this demo. It's like you could just download it, and it doesn't install anything on your machine. It doesn't do anything, and when you crash it, when you kind of get rid of it, you stop it, everything disappears. So it's a nice self-contained demo. So I'll try and run it. It's actually running in the background. So I'll kill it, because part of okay, so what this thing is doing is basically running a couple of processes, two that are related to service control, which is like an auditing, it's like a backend service that runs in the background and consumes all the messages that run in the system. In addition to that, there's a monitoring service, so it helps us do all those lovely graphs. And we have our business, not that one. We have a business guys here, yeah. So this one is, no, that's ServiceBus. Sorry, I need my glasses. Thought I could get away with it, I can't. There's shipping, and there's sales and billing, and we have a client that lets us, and each of them have all kind of little cheats that you can enter, so things go faster, slower, and so on. So if you look at our monitoring, as you can see, there is nothing currently running. Sorry, nothing currently in any kind of delayed retries. The throughput is very clear, and processing time and critical time. And if we want to know more, we can drill into each endpoint and see what types of messages are being processed on that endpoint, and learn from that what's wrong, what's stopping us, or what's breaking us. If you go to shipping, I think shipping, for example, has two message types, and you can see that one handles its processing time is 200 millisecond, and the other one is 700 millisecond. So obviously there's there's differences in the throughput. But if you look at the overall throughput, it's, the lazy one wins, yeah? So the one who's slower will show a lower throughput on the endpoint itself, on the whole endpoint, yeah? So we can simulate some problems, for example. First of all, I could increase the, in the client UI, if I find it. There we are. And I can so that now the client UI, so basically generates the component generates the orders, is now generating 8 per second. Now there's something wrong with my deployment. I noticed it earlier that we don't see anything in the queues here, in the queue length. So that's something that's what happens when you play with the demo too much. Screw it up. So notice that the client UI, for example, has no monitors whatsoever, right? It's like it's dead. Why would that be? Is it processing messages? No, right? So there's nothing to monitor, right? From a processing perspective, this is showing us what's being processed. Okay, so we increase the number of orders we run, and immediately we see this. This is worrying, right? When you see something going up all the time, where is it going to end up? In a problem, right? Unless it's you're making money. But even when you're making money, it's a problem because you then get to a certain point and it will dip again, right? Because of self-correction in the universe. So this, so let's look what's happening in sales here. I could make things worse, of course, but we can see that it's just not keeping up, right? Not keeping up with enough. It doesn't process enough messages a second. It takes it, currently it's processing at 1 second and 300 milliseconds. And the throughput is very low. It's like four messages a second. So that means that this will continue to, it's a shame because if we had the queue length, we could have seen it would be very clear that the queue length is also is going to climb up, yeah? Let's make sales go fast. Yeah. So I'm fixing the bug, right? Going to production, deploying the DLLs. Yeah. And now we can go to sales and make it go fast. So now it's processing. I dropped it dramatically to 200 millisecond processing time, and we immediately see that it dips, yeah, and we can, things are looking better now, yeah. A good example here would be I'm not going to go into all that, but in shipping we saw that we had 2 handlers and 2 messages, one slow, one fast. If we can't, we can ramp up those endpoints to multiple threads, but then we'll hit a ceiling, right? There'll be a ceiling where we go, okay, we can't do that. We have to scale out. So that would be a good candidate to scale out because we know that there's something that takes a long time to process. Maybe it's a call to web service or uploading a streaming something or something, very heavy I/O, and that could help us do that. Now, observe that shipping is now clogged, right? I pushed the can down the road, right? Now shipping is, can't process anymore. And let's see if there's anything interesting to do to shipping. Yeah, so we see that we have two handlers. One is kind of normal, 200 millisecond. The other one, 700 millisecond, yeah? and that's clogging up the overall performance for the endpoint. But I can take that handler, put it on its own thing, right? And I can save the situation, right? Make sense? Now I can make things go really bad by adding some failure rates here on billing to 40%. And you can see that now I have a failure rate on that endpoint. So we're getting failures and we retry. So those retries are beginning to show up in the schedule retry graph. The processing, the critical time, the time that takes the end-to-end processing time is increasing. And because if we had another business monitor here, like the number of orders that are being fulfilled, so we have orders coming in, but nothing being, or a lot is, less is fulfilled now, right? Because billing is trying to charge, but it's falling over and falling over. So we'll have a reduced rate of business activity, right? Makes sense? People that are, the orders are not coming out fast enough. Yeah? Makes sense? So technically speaking, we can go here into the retry, the error queue, the error, and I don't think that here we have a lot of stack trace. Oh, we do. Okay. So we have a nice stack trace. We can see the headers, where it came from, what thread it was, what correlation ID it belongs to, what the intent of the message was, and so on and so forth. We can see the message body, not a lot there, but you can actually see the actual thing. And then I can just decide to retry the message. It will put it on a queue to retry, and that's more or less the end of the demo. Is that okay? Any questions about this thing? No? Okay. So if you want to try it yourselves, I think the presentation is going to be up on the published some stage. So the link is going to be there. Right. Okay, so we did this thing. Sorry. Yeah. So how did monitoring save my bacon? So we had a large system. I can't tell any lies now because you're sitting there. It's very bad. It wasn't very small. It was processing a lot of stuff in kind of high-ish rates, and every downtime, every hour of downtime was at a rough figure of 70 to 80,000 pounds. Yeah, so it's like serious loss every time the system went down. And there was this business unit that decided to do a promotion in some other country that I won't disclose. And we asked them, what's the story with the promotion? He said, we expect like 10-20% increase in activity. And he said, 10-20%, we're fine. It's gonna fly. No worries. And they went ahead and published this. It was an ad campaign or something like that on the TV. The morning after we came in, that was after we knew that there's a problem because there were emails flooding in of issues. And we came in and all our monitors were red. Everything was red. Like the system was just going like, and it was killing itself because everything, all the retries were retrying, and every bottleneck now glared, right? So every place where we had the problem is now a big problem. And back then we didn't have this kind of fancy monitoring. Yeah, it was something that one of the developers built. It was we were using some log thing that was looking in, And we kind of could infer from that. It was like you could run SQL scripts that kind of gave you the reason, find the message type and then find the processing time in the logs, and then, oh yeah, that was really, really complicated. Nothing like what you see here. But we did find the bottlenecks, and we did manage to, first of all, we knew way ahead that was a problem. That didn't help us, but at least we came ready. And we redistributed this in a matter of weeks to months, I'd say. Yeah. So we managed to find the bottlenecks, move things around, and very quickly, relatively speaking, get the system back up, performing properly as expected. If we didn't have messaging, that would have been, if it was big monolith, and we had something like that, I don't know what's your experience. I'd say 2 to 3 months. Yeah, fix a big all your bottlenecks in the system, scaling from, except for redeploying the whole system on a bigger machine, okay, that you'll do. That also takes, I don't know, how long does it take to provision a machine, redeploy, retest, do UAT, do this, do that. Yeah, that's a good bit of where we were, because of the fact that we're using messaging, we're able to go, we just take off that endpoint offline, the queue's filled up, redeploy the new endpoint that now has, that now does 2 endpoints in one. In the meantime, fix the issues with whatever kind of were the actual bottlenecks, so what caused the latency, and we're able to run the system again. And I think that was I think we got a lot of credit back then. It got a lot of credit for the fact that the system went down and it was still running, right? And then we're able to fix it like in magic time, because most of the people, that came from other architectures were going like, no, that's it. We can shut down, close the key. That was our pride and joy, the Dublin office, yeah. So so that was my little bit of that saved my bacon. And I hope that if you kind of take the kind of the little bit of things from this talk, it can save your bacon as well. So, turn the lights on. Anybody like here to drive 200 kilometers an hour in dark night without the lights on? I know many volunteers here that will do it, right? But we do it all the time, We drive 60 kilometers an hour in fog, where we can't see like 2 meters from. But that's the equivalent of that. So turn the lights on. Get serious about it. Remember that if you're doing distributed systems, they are durable, and if they're not, you shouldn't be doing the durable. You shouldn't be building distributed systems. So they're durable. They won't tell you anything until it's very much too late. A lot later than what it is in a monolith. And try and get all of the monitoring aspects covered, and think of that idea. Yeah. So cover the basics for sure, but then try and get to the next and the next level in all these kind of little those places where things can make your life a lot better and help you get a better monitoring system. And I think there's also, if you add a little bit of love to the business, you get even more value out of your monitoring system. Yeah. Okay. Questions?